Okay, so I have 4 series written here. I want to know what kind of series they are, and I want to know if they converge or diverge. Let's make this one a little harder. Let's put a +1 there just for fun. First series, what kind is it, and does it converge or diverge?
It's geometric.
And how do you know it's geometric?
Power n.
It's got something to a power n. This one's geometric. Converges. Why does it converge?
It converges to solve it because it's in between -1 and 1.
R is 3/5, so R is between -1 and 1. So it converges to 1 over 1 minus 3/5, which is 1 over 2/5. So that one converges to 5/2. Second series. What kind is it? Does it converge or does it diverge? What if I had to put that little +1 there? Then it's geometric because it would just be 5/2 to the end. You could combine those, right? What's that little +1 do to it? Makes it confusing, doesn't it? We're going to rewrite this. This is the sum from n equals 1 to infinity of 5 to the n over 2 times 2 to the n. What did I just do? I broke it down. I used properties of exponents. If I multiply these two things, 2 times 2 to the n, I would add my powers and I would get n plus 1. So that's what you're going to do with things that are almost geometric but the powers don't match. You're just going to peel the powers off to make them match up. So this is now the sum from n equals 1 to infinity of 1/2 times 5/2 to the n. So what kind of series is that? That's a GO also. Converges or diverges? Diverges because R is 5/2, which is bigger than 1. This is a divergent geometric series because R is 5/2, which is bigger than 1. Next one. P series. Why is it a P series? Because it's in the form of n raised to a power. That's the P series form. Converges or diverges? Convergent because P equals 3, which is bigger than 1. Which makes the last one kind of easy. The last one is also a P series because it's in the form n to a power. Converges or diverges? Divergent. Because P equals 2/3, which is less than 1. Okay. Section, what's the next section number? 9 point something. 3. 9.4. 9.3 we already did. Section 9.4. We're going to have 2 more ways to determine if a series is convergent or divergent. And these are known as comparison tests. The first one is called the direct comparison test. It says, assume that a sub n is positive and a sub n is always less than or equal to b sub n, which of course forces b sub n to be positive also. If the sum from n equals 1 to infinity of b sub n converges, then the sum from n equals 1 to infinity of a sub n also converges. Why does that make sense?
Because if b sub n converges and a sub n is less than or equal to b sub n, a sub n has to be within that range.
Exactly. What this is saying is, you add up all the b sub n's, you get some number. You're not getting infinity. And the a n's are smaller than the b n's. So if you're adding smaller numbers, you're going to get a smaller answer, aren't you? You're not going to get infinity. So when this one is small, when this one converges, when this one is not infinity, since this one is even smaller, that one can't be infinity either. It has to add up to a number. Conversely, if the sum from n equals 1 to infinity of a sub n diverges, then what has to happen?
b sub n must diverge.
The b sub n's have to diverge. How come?
Because a sub n is bounded by b sub n.
And the a sub n's are adding up to infinity, and the b sub n's are even bigger. So the b sub n's would have to diverge also. Okay, so here's how we use this theorem. Consider the sum from n equals 1 to infinity of 1 over n squared plus 4. Is that one of the series we know? We only know 3 right now. We know telescoping, we know geometric, and we know p-series. Is that one of those? I don't think so. Why not? How come it's not telescoping? The bottom doesn't factor. You can't use partial fractions. How come it's not geometric?
Powers in there.
We would have to have something raised to the n, not n squared. How come it's not a p-series? Because of the plus 4. But it's really close to a p-series, isn't it? If this 4 were gone, you would tell me that's a p-series. And what would you tell me about that p-series? Does it converge or diverge? It converges because it's a p-series. P is 2, which is bigger than 1. So, is this true? Is 1 over n squared plus 4 always less than or equal to 1 over n squared?
Yes.
Yes, how come?
There's a number on the bottom, and the last one will be bigger.
When you make the bottom bigger, it makes the entire fraction smaller. So, we can use a direct comparison test. We have that our series, our terms, are less than or equal to 1 over n squared. And what do we know about the sum of 1 over n squared? It's a convergent p-series. Since this is convergent, and this one's even smaller, that one has to converge. This is convergent by direct comparison test with 1 over n squared. So that's the kind of answer I would expect to see on your test. I would expect you to tell me it's convergent, and I would expect you to tell me what test you're using. Because we're getting to the point where we have quite a few tests, don't we? We have geometric, telescoping, p-series. Then we had the integral test, and now we've got another one called the direct comparison test. So at this point, we have 5 different ways to decide if something is converging or not. And so you need to tell me which of those 5 ways you're using to determine your answer. Questions on that? All right, how about the sum from n equals 4 to infinity of n over n squared minus 5. First off, why did I start at 4 and not start at 1? Yeah, I didn't want to have negatives on bottom, because to use our comparison tests, everything has to be positive. I also wanted to make sure I knew I was going to put a subtraction on bottom, so I wanted to make sure I didn't get 0 on bottom either. I can't have 0 on bottom. But the big thing was I had to make sure things were positive. All right, so what you have to do, you have to kind of look at that series. And you have to first make an initial guess. Do you think that series is convergent or do you think it's divergent? Because that determines what you're going to compare it with. Why do you think that series is divergent?
I feel like I compared to the same thing that are there.
But that one was convergent.
I know, but this will be greater than that.
Okay, but notice that doesn't do you any good. If this one converges, and you're going to compare this one with that one, then you think this one converges. You need them to do the same thing. If this one converges, that one converges. If this one diverges, that one diverges. So if you think this one diverges, you don't want to compare it to that because that one we know converges. They need to do the same thing. Converge or diverge? You got a 50-50 chance of being right? Converge. No, sorry, you're wrong.
Someone said diverge. I feel like we could modify that to make it work for us.
Okay.
Like
Modify it how?
Negative in front of it,
No, not
so
negative.
positive.
Remember what I did with this one? This first one, I kind of covered up the 4 and said that looks a lot like 1 over n squared. On this one, I'm going to cover up the minus 5. I'm going to look at the biggest powers. If I look at the biggest powers, what does that one look like? It looks like 1 over n. And what do I know about the series 1 over n? It's divergent. How come? It's a p series of p equals 1. That was one of the famous ones. That was the harmonic series. So that's kind of what you want to do with these. You want to begin by looking at the biggest powers at the top and the biggest powers at the bottom and looking at them and say, that looks a lot like 1 over n. So my guess is that this thing diverges. So now the question is n over n squared minus 5 bigger than or equal to 1 over n? Why do I want it to be bigger than or equal to this time? The first time I went with less than or equal to. This time I want it to be bigger. How come? Because this one's divergent. If this one is even bigger, then that one's going to diverge. Back up here, I thought this one was convergent, so I wanted it smaller than a convergent. So you see how that goes? If you think it's convergent, then you want it to be smaller than a convergent. If you think it's divergent, you need it to be bigger than a divergent. Is that true? Is n divided by n squared minus 1 always bigger than or equal to 1 over n? No? When it goes to infinity, this one gets close to 0, that one also gets close to 0. So they're both getting close to the same thing. But is it bigger? Yeah, why?
Because isn't it really kind of like 1 over n is kind of like n over n squared, and the minus 5 on the left is smaller.
So what you're saying is think of this as being n over n squared, and then you're absolutely right. Here, I'm subtracting 5, which means I'm making the denominator smaller. When I make the denominator smaller, what does that do to the entire fraction? Makes it larger. So this fraction is larger than that fraction, which is the same as that fraction, which is nice. So, I think we're done. We have our fraction here is bigger than or equal to 1 over n, and we know that 1 over n is a divergent series. So, our answer would be, this is divergent by direct comparison test with 1 over n. Questions on that? All right, let's do one more direct comparison test. Then we'll look at the limit comparison test. How about the sum from n equals 1 to infinity of 1 over the square root of n cubed plus 1. Once again, you need to start by deciding if you think this is going to converge or if you think it's going to diverge. And that tells you what you should compare it with. Do you think that converges or do you think it diverges? Why do you think it converges?
It's kind of like 1/n.
Again, you look at the highest power on top and bottom, which means basically you cover up that plus 1. That's 1 over the square root of n cubed, which is the same as 1 over n to the 3/2. So, this looks a lot like n to the 3/2. And what do I know about 1 over n to the 3/2? It's a convergent p-series because p is bigger than 3/2. P is bigger than 1. Which way do I want my inequality to go? Less than. Why do I want it to be less than? Because I'm guessing that this converges. If I'm guessing that this converges, I need it to be smaller than something that converges. So when you're going for convergent, you want the less than sign. When you're going for divergent, you want the greater than sign. So again, my answer would be convergent by limit comparison or direct comparison test with 1 over n to the 3/2. Questions on that? Okay, well the problem is the direct comparison test doesn't always work. How about if I were to give you the sum from n equals 5 to infinity of 1 over n squared minus 2? I would look at that and I would guess that, does that converge or diverge? My guess would be converges. Why do we guess that it converges? Because it looks a lot like 1 over n squared. What's that? And p is 2. It looks like a convergent p-series. So what I would really want to do is I would want to have 1 over n squared minus 2 and 1 over n squared. In which way do I need my inequality to go? If I'm going to use the direct comparison test. I need it to be less than. Unfortunately, that's not true. Why is that not true? Because the minus 2 is making the denominator smaller. When you make the denominator smaller, it makes the entire fraction bigger. So unfortunately, my inequality has to go that way. And then the direct comparison test doesn't work. I know this one converges, but that one's bigger. That doesn't do me any good. It doesn't do me any good to know that it's bigger than a convergent series. I need it to be smaller than a convergent series. So unfortunately, the direct comparison test only works in very special cases. It works pretty much where you have something plus 1, and that makes it smaller and makes the convergence work. It does not work for this problem. The good news is we can fix that with what's called the limit comparison test. The limit comparison test says let 0 be less than an and 0 be less than bn. Again, I need those two things to be positive. If the limit as n goes to infinity of a sub n over b sub n equals L, where L is finite and positive, then the sum of the an and sum of the bn's both converge or both diverge. Basically, they do the same thing. All right, so here's how this would work. The sum from n equals 5 to infinity of 1 over n squared minus 2. We're going to use limit comparison test with the sum of 1 over n squared. We're pretty sure this converges because we cover up that minus 2, we have a p-series, we know that p-series converges. So we're pretty convinced this converges, which means I want to compare it with that convergent p-series. I now take the limit as n goes to infinity. Which one's a n and which one's b n?
The original would be a n.
Truth is, it doesn't matter. Whichever one you like. The original's a n, so 1 over n squared minus 2 divided by 1 over n squared. If that limit is a number other than 0, because it has to be finite and positive, if this is some number other than 0, since I know this one converges, that tells me the other one will also converge. They both do the same thing. What's that limit? Can't be -1. It's got to be a positive number, because these are all positive, those are all positive. It can't be a negative number. Could be 0, but it can't be a negative number.
No. 1.
1? Why 1?
Because if you flip and multiply, you have the same power on top and bottom.
This is the limit as n goes to infinity of n squared over n squared minus 2. You take the bottom, you flip and multiply, and then we notice we have the same power on top as we do on bottom. So we look at our leading coefficients. That limit is 1. All right, so we took this limit. We got a positive finite number. We know that series converges. So by the limit comparison test, we can say that series also converges. Questions on that? All right, let's try a few more of those. How about the sum from n equals 1 to infinity of 2 to the n plus 3 over 5 to the n minus 8. Once again, I got to begin by looking at that, and I got to begin by making a guess. And my guess will kind of tell me what I should probably compare it to. What's our guess? Do we think that converges or diverges, and what are we going to compare it to? We think it converges because you took away the 3 and the 8. It looks like 2/5 to the n, which is a convergent geometric series. So those two things kind of go together. Your guess of if you think it's convergent or divergent and what you should compare it to kind of come together. So it looks like we should do limit comparison test with the sum of 2/5 to the n, which we know is a convergent geometric series. Okay, so to do the limit comparison test, we take the limit as n goes to infinity, 2 to the n plus 3 over 5 to the n minus 8 divided by 2/5 to the n. How much is that? 1? Why 1?
Because it's the same thing, you're going to put the same power on top and bottom, and the leading coefficients cancel out.
That kind of works when we have n cubed. I'm not sure that that's true for 2 to the n, though. I think we want to do the same thing, the same sort of trick. And I think you're right. I do think it is 1. 2 to the n plus 3 over 5 to the n minus 8 times 5 to the n over 2 to the n. Flipped and multiplied. How much is that? Well, I'm going to write it like this. This is the limit as n goes to infinity. What happens when I take 2 to the n and I divide it by that 2 to the n? I get 1 plus, what's 3 divided by 2 to the n? I don't know, it's 3 over 2 to the n. This one's a little weird. What's 5 to the n? No. Yeah, over 5 to the n minus 8. So I do think we get 1, because now what happens when n goes to infinity? I have 1 plus, this limit is 0, and then down on bottom this limit is 1, because I could use, if I really had to, I could use L'Hopital's rule, take the derivative of the top, derivative of the bottom, that 8 would drop out. So I think you were right, Ben, that limit is 1. Right. It was a good guess. So our answer is convergent. I used the limit comparison test to prove it. Not a question. Questions? All right, let's try a couple more of those. How about the sum n equals 1 to infinity of n over n plus 1 times 2 to the n? Once again, you need to kind of make a guess, converge or diverge, and a lot of times that guess is going to tell you which series you should compare it to. Converge or diverge, and what's your comparison series? Well, what's going to happen when n gets really, really big? What piece is going to be important when n gets really, really big? The n over n plus 1 or the 2 to the n? The 2 to the n, how come? What's going to happen when n gets really, really big? What's going to happen to this n over n plus 1? It gets really close to, not 0. It's close to 1, doesn't it? I mean, if n is like 1,000,000, you have 1,000,000 divided by 1,000,001. That's really, really close to 1. So what's the important piece? The important piece is this 2 to the n. So I think we should do the limit comparison test with that. And what is that? Is that a convergent or a divergent series? Convergent, what kind of series is it? It's geometric, because I could write it as 1/2 to the n. So once again, to me, my initial guess is I'm going to be able to use a limit comparison test. I'm going to be able to compare to this convergent geometric series. So my guess is that that thing is convergent. But to be sure, I have to take the limit as n goes to infinity of n over n plus 1 times 2 to the n divided by 1 over 2 to the n. I flip and multiply. When I flip and multiply, I'm left with the limit as n goes to infinity of n over n plus 1, which is 1. Convergent is my answer. Questions on that? I have a question. Seems like for every one of these problems we've done, our limit was 1. Our limit was 1. Our limit was 1. Is the limit always 1?
No,
Absolutely not, unfortunately.
it's never that easy.
It's never that easy.
If it was, then you just plug in somewhere.
No, it's not always 1 though. I'll give you a very simple example where it's not 1. How about the sum from n equals 1 to infinity of 1 over 3n squared plus 5? Again, you need to make your initial guess, which develops your initial series for comparison. What should I compare that to? Which geometric?
1/3 times 1 n squared. Never mind.
P series,
P series, which P series?
1 over 3n squared.
Except this 3 we could really just pull out, couldn't we? So really we compare it to 1 over n squared. So again, that you just look at your powers. That looks like a P series. So I think I'm going to compare to that. And this time I'm going to have a limit as n goes to infinity of 1 over 3n squared plus 5 over 1 over n squared. That's the limit as n goes to infinity of n squared over 3n squared plus 5, which this time we get 1/3. Does it matter that we get 1/3 instead of 1? No, because what did we need to end up with? A number except for 0. If you get 0, the test fails. So convergent. Nick.
Wouldn't we just use the direct comparison test?
Absolutely, this one you could use the direct comparison test because 1 over 3n squared is less than or equal to 1 over n squared, isn't it? Because you're certainly making your bottom bigger, which makes your whole fraction smaller. So absolutely. Some problems you can use either test. This is a good example of this problem. You could have used the direct comparison test, or you could use the limit comparison test. If you can use the direct comparison test, the limit comparison test will always work. But the converse isn't true. Sometimes you can use the limit comparison test, but the direct comparison test wouldn't work. So, for me personally, I pretty rarely use the direct comparison test. I almost always use the limit comparison test because I have a higher chance of working for me. But if you recognize immediately that the direct comparison test is going to work, the direct comparison test is easier to use. So if you can use it, if it works, it is easier. All right, last one for today. How about the sum? N equals 1 to infinity. Sine of 1 over n. Trig functions. Can't forget about our trig functions.
That's going to be divergent.
That's going to be divergent. How come?
It's going to oscillate between 2 points.
Yeah, but think what happens though. I agree it's going to be positive, negative, it's going to oscillate around. But what happens when n gets really, really big? This gets really, really close to 0. So sine of this thing is getting really, really close to 0. So I agree they're alternating back and forth a little bit. But they are getting closer and closer to 0, aren't they? So it's not like they're oscillating between -2 and +2. in which case we would definitely say divergent. I do think you're right. I do think it's divergent.
You just look at one more.
You're going to compare it to 1 over n?
I don't know.
I don't know. That would be my guess. That seems like the most reasonable one to work with. We know that that's the harmonic series. We know that one's divergent, so I'm guessing that one's divergent. I'm going to take the limit as n goes to infinity. Sine of 1 over n over 1 over n. How much is that? 0? I hope it's not 0. Because if this limit is 0, then the limit comparison test fails. I need the limit comparison test to give me a positive number. So I hope it's not 0. It's 1? Why is it 1? Ah, very good. Somebody's remembering his Calc 1. Remember, in Calc 1, we had a theorem that said the limit as x goes to 0 of sine x over x is 1. So when you had sine of 0 over 0, you got 1. Isn't this in exactly the same format? This is sine of 0 divided by 0, and these things match perfectly. So that limit is 1. That's not the way most people would answer it, though. It's not how I would have answered it. It's not what I was thinking of. What I was thinking of is this is in the form 0 over 0. What do I do when something's in the form 0 over 0? I use L'Hopital's rule. So I would have said this is the limit as n goes to infinity of cosine of 1 over n times what's the derivative of 1 over n? Negative 1 over n squared. The reality is it doesn't matter what the derivative of 1 over n is, because on bottom I also need to take the derivative of 1 over n. So if I have the derivative of 1 over n on bottom and I have the derivative of 1 over n on top, they're going to cancel out. Cosine of 0 is 1. I think that's how most people would have answered that problem. That's how I would have answered it. But I like Edward's answer very much. That's a very good answer. Questions on the direct comparison test or the limit comparison test?
So if L isn't finite or positive, is that just inconclusive?
That's right. So if I were to do this limit and I got the answer of 0, or I got the answer infinity, the limit comparison test didn't work. Which tells you one of two things. Either the limit comparison test will never work, or you didn't use the right series to compare it to something. You don't, unfortunately. You hope it works. If not, then you try again. Try something else. We will have some other techniques in the near future to fix that problem. Like Friday, for example. We'll have 2 more tests. The ratio test and the root test. I think that's the next section anyway. Oh, nope, the next one's alternating series. Root test and ratio test is the one after that.